Hey guys, Matt Palumbo here from Audiocontrol, and on today's workshop, I'm going to give you a quick walkthrough of Audiocontrol's easy-to-use DSP software called DM Smart DSP. Stay with me. First step is Input View. In DM Smart DSP, our software is organized into two main tabs with one additional kind of accessory tab. The first one we're going to look at is Input View. When we take a look at the Input View, it's really organized pretty easily. Up at the top here, we have our 8 different inputs. On this product that we're using for today's demo, it has 8 inputs because it's the DM810. The software will automatically configure itself based on which product is plugged in, so you can't select the wrong number of inputs. Right up here, it shows DM810, and basically you can't choose the wrong piece. So first things first, we're going to look at our input channels. We have 1 through 8 right up here at the top. The first thing that I usually like to do is click on my different inputs and see what I have coming in for signal. You can easily do that in DM Smart DSP because we have a built-in electrical RTA on all of the input channels. Now, that commonly gets confused with a RTA that would be used on a microphone, which is what people think of with DSP because they think of tuning the car. Remember, we are at the very starting stage of setting up this DSP. We are not tuning anything yet. We are just setting it up and configuring it. So when I say RTA, I'm talking about an electrical RTA. It is actually measuring the electrical input signals coming into the product itself. So let's take a look. When we come down here to the RTA section, I can see that I do have signal coming in. Right now I'm on channel 5 input, but we can look at some of the different inputs as well. If I look at channels 1-2, I can see I have signal coming in there as well. Definitely not a flat signal, but it is full range. When I click on channels 3-4, I have nothing. There's no signal fed into 3-4, so that's what I would expect. When I look at channel 5, it looks like I have a low frequency only channel coming in there, probably a factory crossed over mid-bass driver or maybe a factory subwoofer. And on channel 6, I have a high frequency only input. So again, maybe this is a channel that was running to a top dash speaker or a factory tweeter, something like that. And on channels 7 and 8, I have no input. An important thing to note in this software is that 7 and 8, or whatever the last inputs are on your product. So for example, on a DM810, that's going to be input 7-8. Let's say you were working with a I don't know, let's call it a Audiocontrol D-5.1300. That is going to use the last channel inputs combined for that last little section there. So what I mean by that is on, say, the DM810, we have a optical input and a coax digital input. Those are combined with inputs 7 and 8. They don't have a separate input tab in the input view. On a D-series amplifier where the DSP is built into the amp, those do not have optical or coax digital, but they do have something called front high level. So they have an additional couple of high level inputs, and that's where you're going to see them show up in the software. So let's take a look at the other portions of the input view. The next thing that you'll notice here is we have this input gain section. Input gain is where we can adjust how much of this signal we want coming into the product. You'll also notice that when we look at these inputs on channels 1-2, there is our milk light, which is maximum input level control or clipping. That little indicator is kind of like a dummy light, kind of a check engine light, let's call it. It's a guideline. It's not going to be perfect every time, but it gives amateur users something to target. So basically that's going to allow you to, with the volume knob from your factory radio, turn that volume up while playing music or a test tone, and you can see when that input level is clipping based on when that little digital LED on the screen starts to illuminate. The other thing to take a look at in your input view is your RTA. Now, we already covered this a little bit, and we looked at what signals we had coming in, but something I didn't mention was that we also have some adjustability in this view. So let's say we clicked on channel 1-2, and I'm looking at this signal, and I saw nothing like this. Well, does this mean I have no signal, or am I just not seeing it? If you don't see anything here, you could increase the volume on the factory stereo or aftermarket stereo and see if that signal shows up if you're expecting it to be there. Or you can change the sensitivity of the RTA. In this case, I'm going to turn the sensitivity up by selecting a different dB level here up at the top left where you see 50, 60, 70, 80, 90. So in this case, I'm going to click 50 so that I can see the entire signal there. Now I can take a good look at it. The other thing you'll notice is this FM and S. This is the response time on the RTA. So right now I have it set to S for slow. It makes it a little bit easier to see what's going on with the signal, so it's not too jumpy and tweaky. If I put it to medium, you can see that response time improved and it got a little bit faster. And if we put it to fast, you can see literally what's going on with the signal in virtually real time. Now, why would I want to choose F over M or S? For me, when I'm setting up a DSP, if I'm trying to identify maybe which channel has the door chimes in that channel signal, I'm going to want to put it on F so that I can see the signal spike every time the door gets opened and that dinging noise goes off. If I'm curious and I think that dinging is coming through the speaker path, through the signal path from the speakers, I could choose that channel and look for it right there on the RTA. If you're not trying to do that or identify something like that, sometimes the slow or S mode is a little bit easier to look at. So once you've identified all of your different input channels and you've seen what you have coming in for signal, even if you didn't test any of your signals ahead of time with, say, something like the DMRTA, which you definitely should, but even if you didn't do any sort of testing ahead of time, this is still a great way to at least get an initial kind of capture of what you have coming into the DSP, and now you can start thinking about what you want to do with that signal before you feed it out. So the next section in the DM Smart DSP software, and honestly where you're going to do most of your work, is the Output View tab. This is where we're going to set up crossovers, equalizers, signal summing, AccuBASS. All of the primary settings for your DSP are going to happen here. So let's take a closer look at Output View and what you can do with it. When we're looking at Output View, the first thing that you'll notice is that we've conveniently labeled all of these different outputs right up here at the top. So again, this is a DM810 that we're using as an example today, and we have 10 channels of output. So we've gone ahead and labeled those outputs as what they're most commonly used for. Keep in mind, you can relabel any of these outputs or inputs for that matter, just by clicking up here at the top. You can double click and type in something else. So I'm just going to call this test instead. So now you can see I relabeled that from sub to test. So you can name those channels front tweeter, rear tweeter, whatever your output channels are. Same thing on those input channels. Right now they say channel name. Feel free to name those inputs. I highly recommend naming those so that you know which signal's which, whether you're bringing in factory signals from an OEM head unit or you're just bringing in RCAs from a aftermarket source unit. I would still label them and call them front RCAs, rear RCAs, so on and so forth. So when we look at our outputs, we can take a look right up here. We are on output 1-2. So we're going to stay in this main screen in Output View. But when I click on each of these different outputs, it's just going to show me the settings for those. It's not going to switch the whole screen or pop up a new window or anything like that. We try to keep it really simple so that it's easier to use. So when we look at outputs 1-2, the first thing that you might notice is the crossover section. It's an important part of setting up the DSP, of course. What we've done to try to make this a little bit more dummy-proof is we've actually preset the crossover levels at some common values. Now, does that mean that you shouldn't go in and change them? Of course not. You should absolutely dial in the crossovers for your customer's system. But if this is your first time setting up a three-way active front stage and using a DSP, it's good to take a look at these and you can see what we're kind of recommending if you're using our speakers and our products. So you'll notice that the tweeters are crossed over at 4K with a high pass crossover. So we have them set at 4K on up. So they're going to play from 4,000 hertz on up to infinity, right? So when we look at the mid-range channels, we can click on 3-4. Those are set from 350 hertz to 4K. The front mid basses are set from 350 down to 80. And let's go to the subwoofer. The subwoofer is originally set from 90 hertz on down or 80 hertz on down. I've already messed with this one a little bit. There we go. There you can see how it's default set up. The rear speakers are set from the factory at 80 hertz on up. So again, if you're doing a traditional system with three-way components in the front and let's say coaxials in the rear and then a couple of subwoofers or a single subwoofer, the crossovers on here are pretty much already set up for you. Or at least they're a good jump off point. They're a great starting point. So when we look at this, we have a few options in this crossover section. You'll notice that there's a 24, 18, and 12. that's going to be what octave or what slope you want for your crossover. So we have a 12 or 24 dB per octave Linkwitz-Riley crossover, or we can try an 18 dB Butterworth. We don't really have time in this section to go through all the differences in the types of crossovers out there. You can do some research online if you want to learn more about those, but at least you do have some choices. Another nice feature that we built into the crossover section is the ability to bypass crossovers altogether. Let's say you want an output channel that is just full range. I don't want any crossover. That's pretty easy. You just drag this all the way to bypass. Now this channel is not crossing over at all. If I wanted these rear speakers to just be rear fill, let's say I want them to play from 70 hertz on up to 6K, for example, I just did that. All you have to do is slide the little dots wherever you want them to go. If you want to be more specific or you don't like sliding the dots, you can also type a value in. So I can click in this box and type in 80.0 and hit enter, and now I've set it to 80. Pretty straightforward. The next thing you'll notice is the signal summing section. This is important. This is where this output channel is getting its signal from. So when we look at our rear speakers, we need to decide where do the channel 7 and 8 outputs that are going to feed the amplifier, that are going to feed power to my rear speakers, where do I want the signal for those rear speakers to come from? Well, in this vehicle, we had full range signal on channels 1 and 2. So let's say I'm going to select 1-2 as my input. So now the DSP is routing signal from channel 1-2 input to channel 7-8 output. That's what we mean by matrixing when we call our products a matrixing DSP. It means we can assign any input to any output. So now we've got signal flowing from channel input 1-2 to output 7 and 8. The next thing here is our independent levels. We have output levels for each channel in the system. They're going to come preset at just kind of a default level. But if I wanted to tone down channel 7 versus channel 8, I can easily do that just by dragging a little slider. If I wanted to max those out, no problem, we've done that. Now during setup, sometimes it's nice to be able to mute one channel at a time or mute channels altogether just so that you can work on kind of one part of the system at a time. You can easily do that with these little mute buttons here. You can also assign our ACR3, the remote volume control, or bass knob, a lot of people will call it. You can assign that in the software right here where it says remote volume. If this is highlighted, then that bass knob that you install up at the front dash is going to control the volume of that channel. So in this case, maybe I want to have a DSP preset where the knob in the front dash just controls the volume of the rear speakers. I just did that. If I only want that to control the subwoofer volume, then I would only want to have this little box highlighted on my subwoofer output channels. You also have the ability to turn these into a mono set of outputs rather than stereo, and you can link them. Linking allows us to just kind of copy and paste settings from one set of channels to another. So if I'm going to use channels 5, 6, and 7 and 8 all to do the same thing, you can just go through and configure channels, say 5, 6, and then click link, and it's going to link it to the next set of channels. So that way you're not wasting time redoing the same settings over and over again. In our delay section, we have the ability to flip the polarity of each channel 180 degrees out of phase. So if I click that button there, and that little box is kind of lit up that purplish blue color, now my channel 7 output is 180 out of phase. So it's an easy way to be able to click that and notice if maybe unfortunately something got wired backwards, or maybe there's just an actual phasing issue in the car that you're trying to overcome. We also have our time delay, signal delay, time correction, whatever you want to call it. We call it delay. So this is going to allow us to delay that channel to, generally speaking, the driver's seat. That's how most people do it. We don't make you do any math, thank goodness. All you have to do is measure. So you're going to measure from each speaker in the vehicle to, what I do is either to the middle of the driver's headrest. Some people do it to their ear or to the middle of their nose. Everybody has a different technique. For this example, let's just say you're going to do it to the middle of the driver's headrest. So you would just measure from channel 7, which in this case would be our rear left speaker, and measure to the middle of the driver's headrest, and then input that number right here. Let's say it's 45 inches. So all I've got to do is put that in and hit enter. Same thing on the rear right channel, or I can drag the little sliders if you prefer. So we don't make you do any sort of math when it comes to time correction. All you're doing is entering numbers or dragging sliders. Now on that topic, this is set to inches as default. If you would prefer to do it in centimeters, you can do that in the Tools menu. Tools menu is up here in the top left corner. Click my drop down. I can change my output delay unit. If I click this, you'll see it's now in centimeters. So pretty easy to do. As I come down here, we have AccuBASS. AccuBASS is going to be, Audiocontrol's patented technology that we use to overcome bass roll-off in factory sound systems. We've all done systems before where when it's all done, we're trying to set up the gain and tune the amplifier. And unfortunately, at the end of the day, we end up with a system that has too much bass at low volume and not enough bass at high volume. Well, AccuBASS helps to overcome that. This is where we set AccuBASS up. So threshold is when AccuBASS kicks in. Level is how much AccuBASS kicks in. So we have lots of videos out there on setting up AccuBASS. We're not going to take a lot of time today to dive into that since this is supposed to be a quick walkthrough. If you wanted to hear the difference between AccuBASS engaged and not engaged, we do have the bypass button. So you can get your AccuBASS settings where you think you want them and then click bypass to hear the difference with or without AccuBASS. And down to possibly one of the most important parts, this is our EQ. We have two different styles of EQ with Audiocontrol. We have both a graphic EQ and a parametric. If we go to graphic, we can just take these little dots and slide them up and down. So if I want to adjust 50 Hertz, I can easily do that. We also have an RTA that's overlaid in this view. So I'm going to adjust that RTA so that I can see my signal a little bit. Now you can see it. And as you make changes in this EQ, you are going to be able to see those changes happen in the RTA. So you'll see I just brought 80 Hertz way, way up, and you're going to see that change happen in the background in real time, even without saving. So it's all happening live as you're making those changes. Now, let's say you have a crazy EQ like I just did, and you want to just kind of start over. We can just hit flat and say yes, and it's going to just flatten us back out and let us just wipe the slate clean and start fresh. We can also mute these channels down here. So if we're in the portion where we are tuning the system, it's easy to just click mute, and I can mute these output channels altogether. If I prefer, I can also do an auto tune. Now the auto button has a few requirements. What this is going to try to do is flatten out the signal the best that it can. So if you are trying to overcome a OEM sound system and you're pretty sure that it has kind of a goofy factory EQ curve to it, what you can do is click auto, and it's going to bring up this screen, and it's going to ask you a few questions. Are we playing pink noise? Make sure it's not clipping, so on and so forth. Once we're sure, we can hit yes. We're going to wait for it to do its thing, and don't close the app. And the DM Smart DSP software is going to make some changes in the EQ and try to flatten out this signal as best as it can for us. I'm going to click yes, and you can see it made some pretty moderate changes. It didn't make anything too drastic, but the idea here is if this signal was horribly goofy and had all sorts of factory EQ applied, then our software is going to try to flatten it out as best as it can for you. Now, of course, any sort of auto feature like that is not generally going to be perfect, but again, it's a great jump off point, and it gives you a great time saving feature, so you're not wasting time trying to correct signal manually. Now, if you've been doing this a while and you would prefer to use a parametric EQ, you can click PEQ over here on the top right of the RTA EQ section. And now we have a parametric 10-band EQ instead. So in our parametric EQ, we can, same thing, we can grab any of these little bubbles down here. These are your different frequencies. And I can drag these not only up or down, but also left to right to select a different frequency. So, a lot of people don't always understand what the difference is between graphic and parametric. That's the biggest thing that you'll notice is with a graphic EQ, all of your different bands are preset. So these bands are set at 80 Hertz, 100 Hertz, 125, 160, so on and so forth. But what if you wanted to adjust at 92 Hertz instead of 80 or 100? Well, if you go to parametric, you can do that. I can either click down here in the little white box and actually type in 92 and hit enter, or I could just click here on the little blue bubble and drag it side to side and choose my frequency that way. The other thing that you can do with a parametric EQ is adjust the Q. The Q is going to adjust, what the shape of that bell is when we're adjusting the EQ. We have these little red dots down here that you can either drag to be more narrow or wide, Or there's also a setting right up here in the top right with a slider, and you can do the same thing. So we'll make a couple of adjustments just for fun, just so you can kind of see how this works. And you can see how important it is to have that built-in electrical RTA working in the background, because it's literally showing you what you're doing to the signal in real time without, again, having to save anything or even play any audio for that matter. All you really need is pink noise playing, and you can do exactly what I'm doing right now and see what the signal looks like as you're manipulating it. One other kind of neat feature in this section of the software is the RTA memories. This is where we can actually go in and we can save kind of a snapshot of the RTA section while we're tuning. So this is going to be more of an advanced tuning feature for those that really know what they're doing with this software, but we have up to 6 store settings and then 6 recalls. So I'm going to show you what that does. If I click store number 1, I'm going to click yes, and then I'm going to flatten this out real quick, hit yes, and we are going to go back in and hit recall number 1. And you can see in the background there, it kind of ghosted that other RTA in the background a little bit, and it makes it just a little bit easier to compare like before and after you made a change. It's an easy way to kind of A/B comparison. So there's another feature in this section of the software that you can't see right now, and that's kind of the fun part. When we go into the tools menu, and again, this is going to be for advanced users that really know what they're doing with DSP, but if you have a vehicle that has all-pass filters and you want to try to undo those by applying another all-pass filter, or you're just trying to create a pretty good 2-seat tune, you can use all-pass filters to do that. If you click Enable All-Pass Filter Settings in the Tools menu, you'll notice that over to the right-hand side of the software, we now added an extra section, and we have up to 2 filters per output channel. So on a DM810, that's going to mean you have up to 20 all-pass filters. Honestly, more than you'd ever need. Right at your fingertips, you can do whatever you'd like with them. They're all there for you to use. If you don't know what an all-pass filter is, let's disable those and not mess with them, because if you don't know what you're doing with an all-pass filter, it's definitely not something you want to mess with. Something that I didn't really mention that I wanted to address and I wanted to show on purpose here was, let's say that we needed to combine some signals together using signal summing to achieve full range. When we took a look at our inputs, we noticed that on channels 5, we had a low frequency only signal. If we look at this again, you'll notice only low frequency coming in on channel 5. And on channel 6, we only have mid and high frequency. Let's say those are the only inputs you have coming from your factory system. Well, if you just choose one or the other, that's not going to be a very good sounding car, right? We're going to need to get full range so that we can do our job properly. So let's go back to output view and let's take a look at this. Let's say I wanted to use channels 5 and 6 as my inputs. Let's say I don't have any input on channel 1 and 2 for this scenario. So what I would want to do is I would select channels 5 and 6 to sum them together. When I do that, it's going to combine the signals and give me the result of it on my output. So we're on channel 7 and 8 output, and I just chose channels 5 and 6 inputs as my signal source for that output. So we're going to mix channels 5 and 6 together. Now, let's scroll down and see what the result of that is. Now, it might look a little bit goofy, but keep in mind, we have a crossover applied, right? So let me undo this crossover for a moment. There we go. And you can see we do actually have a full range signal. By combining channel 5 and channel 6 together, we were able to achieve full range. The only problem is you can see the mids and highs section is definitely going to be a fair bit louder than the lows because that signal was weaker and the mids and highs signal was stronger. So how do we combat that? We can go back into our input view and we can just take channel 6, which is the stronger of the two. We could bring its input gain down a little bit. Let's try to get it to approximately that blue line. Then we're going to go to channel 5 and we're going to bring it up a little bit, and same thing, try to get it to that blue line or pretty close to it. Bring this up just a little bit more. All right, that's pretty close. And now let's go to our output view again and take another look. You can see we now have a much more flat signal. Now again, when signal summing, it's never going to be perfectly flat, but you can see it's a dramatic improvement over what we had a few minutes ago. Let me clear out those RTA memories in the background just so that it looks a little cleaner. There we go. So now you can see exactly what I mean. If we only choose channel 5 as our signal, this is what we would be putting out to our speakers. Just low frequencies and a little bit of mid-range. If we chose only channel 6 as our signal, we would be putting out a little bit of mid-range, mid-bass, and high frequencies, neither of which are going to be great if those rear speakers are a nice set of 6x9s, right? So if we combine the two by signal summing, we make sure 5 and 6 are both selected. Now when we come down, you can see now we have a full range signal. So hopefully that makes signal summing a little bit easier to understand in our DSP. The last section that I want to talk about, and just real quick, is the dashboard view. Dashboard view gives you just a brief overview of basically everything you've already done. To be totally clear, there's nothing in dashboard view that you can't do in input or output view. It is just a kind of summary of everything that you've already been working on, and it allows you to just get a quick snapshot of what you have going on. So once you're in dashboard view, it kind of reorganizes the tabs a little bit and gives you just a different way to work with the information. Again, there's nothing in dashboard that can't be done in the separate input output views. And as far as a workflow goes, I personally prefer to work on my inputs, then work on my outputs, and away we go. Some people really like dashboard view, and that's fine. It's helpful for those that love it. Something I didn't really mention is in dashboard view, if we wanted to say, we're looking at the RTA and we notice, oh, I want to make a little bit of a change, you can just click on the output EQ and it'll actually bring it up to full screen and expand it. So now we have that entire screen to work with. It's a lot easier to EQ on a much bigger platform like that. And again, I can still switch between my parametric and graphic and do all my work that I need to do. And I just click outside of that to go back to the main screen. Now, something I didn't mention in the software is how to save presets. At this point, let's say I've got everything kind of dialed in where I want it, and I'm ready to save a preset. All I've got to do is click it and hold on the number 1 over here where it says memory, hold to store. So I'm going to click and hold on the number 1. It's going to ask me, am I sure? I say yes. And I just saved all of that data to preset number 1 in the DSP. Now, something I get asked a lot is most people understand, okay, so I can do a preset that has the time alignment settings for when I'm by myself and everything is centered for me to try to get the best soundstage and imaging. Okay, great. What if I don't want to do any of that? What if I don't want to use time correction? What if I just want to have, I've got a customer that isn't interested in DSP presets. We're putting a DSP in their car because it's going to make their car sound great, but I'm not really interested in using the presets. What do? You can just copy and paste this preset to all 4 so that if they accidentally switch to a different preset, it's already written in there that it's the exact same settings. And all we have to do that is while we're on the preset we want, in this case number 1, all I've got to do is click and hold on number 2, and it's just going to copy and paste all my settings from number 1 over to number 2. Same thing, I would then do it again from number 2 to number 3 to number 4, and now all 4 presets would be exactly the same. Otherwise, you can click on preset number 2, go in and make some changes, and then click on number 2 again and hold it to save it and have separate settings for each preset. And you can have totally separate settings for each preset. You can select different inputs, different outputs, different time correction, different crossovers. I mean, literally all 4 presets could be a totally different sounding system. The last thing that I want to mention in the software is how do we save all of this? What if there is a problem? What if the system gets stolen? What if the customer messes with the DSP? What if the car ends up in the lake, right? What are they going to do when they bring me back their next DSP? How am I going to have to do this? Like, do I have to redo the whole tune and start all over? Absolutely not. All we have to do is click on File Manager. You'll see right here it says Site File Manager. I'm going to click Save As. And I'm going to click yes. And then all I would do is go in and name the file. It's pre-named for you with the name of the product, and it's going to have the date for today. I recommend calling that something like the year, make, and model of the vehicle or your customer's last name. always save a backup copy of the DSP settings. That way, if God forbid your customer goes home, downloads the software, and gets into it and starts making changes, and unfortunately now the system doesn't sound like it used to, which is probably what would happen if that was the case, then you can be the hero and simply plug into their DSP, go to File Manager, and click Open, and just open up that file that you had saved for them when you initially did the tune. It's going to put all your good settings back into the DSP, and away you go. You're now the hero, and you save the day. The last thing I should mention in here as well is that in the Tools menu, you'll also see that we have some different language options, and we have something called Change Pin. This is another common question we get when it comes to DSP, is I'm afraid my customers are going to mess with this. After I spend 2 hours of tuning their car, or 45 minutes, or 4 hours of tuning, whatever it is, what do I do to prevent them from getting in there and messing with it? And there's differing opinions on this. Some people say, hey, they paid for it. It should be up to them. If they want to mess with it, let them. Others say, no, that's my work and I want to protect it. Either way, I'm not here to debate it, but I'm going to show you how to do it. If you click Change Pin, it's going to ask you to enter the current pin, which is 1234. If you wanted to change that, all we would do is enter 1234, hit OK, and then just enter a new 4-digit pin. It's pretty straightforward. So if you're going to do that, I highly recommend always setting the pins to the same thing. Maybe it's the last 4 digits of your shop's phone number or something along those lines. Well, that's about it for me today. I'm Matthew Palumbo with Audiocontrol. Thanks so much for taking a look at DM Smart DSP with me today, and we'll see you on the next one.